Given the function f of x, find a formula for the inverse. Also, determine the domain and range of the original function. In order to find the inverse of a function, the f of x, let's just rewrite as y first off. Now we have to switch the x's and y's and solve for the new y. You can either solve for the original x and then switch it to make it a y, or switch first, which is what I usually do. So it'd be x equals 3 divided by y minus 2, and then solve for y. This is a rational equation. To solve rational equations, we multiply by the common denominator to get rid of the fraction. I'm going to distribute on the left. This is yx minus 2x equals 3. I want to solve for y. So if I add the term without the y, that helps. We now have yx equals 3 plus 2x. Then if I divide by x, I will have solved for y. So this is the inverse function. This is assuming you didn't make any mistakes. Y equals 3 plus 2x over x. You could choose to distribute this division and have 3 over x plus, and then in the second term the x's would reduce just 2. But either way, doesn't matter. I will write the first one. 3 plus 2x all over x. That's our inverse function. The domain of the original f. X cannot equal 2. We have a choice of interval or set notation. Let's do set notation. The domain of f of x equals the set of all x's such that x not equal to 2. So our answer is saying that every x is good. Every x is the domain except for the negative 2. Now just the x not equal to 2 tells you what isn't in the domain. It doesn't answer the question what is the domain. Now for the range of f, we have two ways to do this. You have to know that this function f is a rational function. The horizontal asymptote is at 0, so the graph in general won't hit y equals 0. So the horizontal asymptote is the exception to the range in general, but there are some problems where that's not the case. So a more secure way, since we have the inverse, is to look at the domain of the inverse. Notice the domain of this function is x cannot equal 0. Now this is the inverse function. The original function, since x's and y's change, would be y not equal to 0, which is the same as the horizontal asymptote. The range is all y's such that y not equal to 0. So the domain of a function is the same as the range of the inverse function, and vice versa. The range of a function is the same as the domain of the inverse function. All right.